Hello everyone, you are welcome once again to today's lesson. And in today's lesson, we are going to continue from where we left off, okay, on the topic vectors. So in our previous lesson, we were looking at, and that was lesson 3. So today's lesson will be lesson 4, okay, on the topic vectors. In the previous lesson, we looked at, okay, perpendicular vectors. Okay, basically that was the main concept, okay, that we learned. Okay, we were still looking at types of vectors. We did the equal vectors, we did perpendicular vectors, and I think we did resultant vectors as well, or we did only perpendicular and resultant vectors. I remember perpendicular and resultant. Okay, however, today's lesson we are going to look at, okay, the last part, the last aspect of what vectors. So our main objective will be by the end of the lesson, today's lesson, okay, the student or the learner should be able to express points, okay, as vectors. Okay, then express free vectors as, okay, or in terms of what position vectors or as position vectors. Then after that, okay, you should also be able to convert vectors in the magnitude bearing form to the column form and vice versa. So these three will be our main objectives for today's, okay, meeting. Stick and stay with me whilst I walk you through, okay, whatever that you need to have these objectives what attained. So first of all, let's look at expressing a point as a vector. Okay, expressing a point as a vector. Indirectly, in our previous meetings, okay, we've made use of this particular concept. So it's now that we are going to treat it what's proper. All right, so anytime you have a point, and every point you know, we'll be talking about points are indicated in the Cartesian plane. So you get the x coordinates and the y coordinates. So assuming this is what I have, this is my Cartesian plane, I have my y axis, and I have my x axis. Oops, okay, forgive me. So my x and y fixed. And in math, anytime we want to, more or less, let me put it this way, yes, we want to prove, we want to show, okay, or we want to buttress a certain point, okay, which deals with a certain concept which deals with the Cartesian plane. Usually we go for the first quadrant, just for the simple reason that we want to avoid negatives. Because in the first quadrant, your x coordinate is positive and your y coordinate is what? Is positive as well, so that we avoid negative. So that's not to say that we cannot use the other quadrant to show or to buttress the point. And I've told you just for the simple reason that I want to avoid negative. So assuming I have a point with the coordinates, okay, so let's say I have a point P with a coordinate xy, and you know that usually points are, the coordinates are stated in the row form. I said usually, I didn't say always. Okay, so assuming I have the point xy and I want to indicate this point, okay, in the Cartesian plane, it means I need to move x units on the x axis, so, and I move y units on the y axis, but I have to start from the origin, which is where the x and y axis intersect. Is that okay? Hello, are you with me? So you can see that I
Yes.
will move from a point, okay, and end at a point. So I will start from the origin, okay, and move x units on the x axis, assuming this is my x unit movement. Then I move y units on the y axis. So assuming maybe this is where I am. So this is where the point P, okay, xy is. Okay, so this is where the point xy is. So you can see that I moved from this point and ended here. So I can join these 2 points, okay, and give it an arrow. Okay, so my line is not that straight, so for obvious reasons, okay, but this is supposed to be a straight line. So I started from here and ended here. So you can see that I moved from O towards P. So it means O to P will give me the vector form of the point P. So every point, you know, takes its source from the origin. And for you to express a vector, okay, in the 2-point form, you need to know your initial point, which is your source point, and your terminal point. Your initial point, your starting point, your source point, or the end point, your terminal point. So you know that your initial point will be O, which is the origin, and your terminal point will be what? Will be P. So it means the vector here will be OP, which we know in the special notation form will be P tilde. Is my point well made?
Yeah,
So
please
it's
come again.
okay. So I said you can see that whenever you are dealing with a vector, okay, when you want to use 2 points, you have to state your initial point and your terminal point, then you put an arrow on top. Am I right?
Yes, please.
Okay, however, here you were given just a point P, and you want to move from what point towards vectors. A point is more or less a scalar. Now you want to move from a point, which is a scalar, to a vector. And I said immediately you want to move from a point to a vector. You need to know your initial point of that point and the terminal point of that point. That's what I said. The initial point of every point will be O. Okay, and the terminal point will be the name of the point itself. So that will be P. So it means the vector here will be OP. So it means every point indirectly is a vector, but it is a special vector, which is a position vector. Is my point well made? Every
Yes.
point is only a position vector. There is no point, okay, that will be a free vector. Take note. All points are vectors, but they are what? Special vectors, position vectors. All correct, my professors. And like I said, just because every point takes its source from the origin. Because if I give you 3, 2, okay, a point maybe, let me use A or the point P, and I give you 3, 2, you know that before you move 3 units, you start from the origin and move the 3 units. And before you get to the 2 units on the Y, you start from the origin, then move. So it means every point will take its source from the origin. Safa, is my point clear now? Okay, so it
Yes.
means if you have the point P, in terms of vectors, it will be the point OP, which you know is a special vector, okay, which will be the same as what small p tilde. The special notation for position vectors. Is that clear?
Yes, please.
Okay, so it means in the same way, if I have the point A, its position vector or its vector form will be OA or A small a tilde. Do you agree?
Yes, sir.
Okay, so the point B will be the same as in terms of vectors, it will be OB with an arrow on top, vector OB, or okay, small b tilde. So in the same way, the point C, what will be its vector from the whole class?
OC.
OC, okay, vector OC with an arrow on top. So OC with an arrow on top. Or,
B tilde.
okay,
B
small c
tilde.
tilde. I hope you are with me now, my professors. Okay, so likewise, okay, this one will be, we know it will be or small q tilde. Okay, and the last one will be what? Okay, OR, okay, then what? Or small r tilde. Safa, because if you
Yes.
don't get this, whatever that I'm going to do next, you wouldn't be able to relate. So please, if this is not clear to you, let me know. Okay, otherwise, I'm sorry to say that the future will be bleak. Okay, so if this is clear, then okay, let me move on to the next one concept. Okay, expressing a free vector as a position vector. So all free vectors, please, if you care to know, okay, you can express it as what? A position vector or as position vectors. Okay, so this is it. Assuming, and again, I'm going to use what? Assume this vector, the free vector AB that we have here, is made up of point, the point A and the point B. Am I right?
Yes,
Yes,
please.
Okay,
please.
very good. So I'm going to assume each of the point, the A and the B, okay, all of them are located in the first quadrant. And I've told you the reason why usually we do this. So it means I'm assuming the A is a point, so its coordinates all will be positive. B is also a point, its coordinates will be all positive. So assuming my A is here, so I have the point A. Okay, so I'm calling this point A. And I have another point which is also in the first quadrant. Okay, just for the simple reason that I want to avoid working with negative. So that point is what? B. Okay, so it means here I'm moving from the vector, the point A to B. So this will be the vector. Is that clear? Is that clear?
Yes, please.
Okay, but we know every point, okay, will take a source from the origin. So in terms of what a vector, I am going to draw a line. A vector will be a directed line segment. So it will be the line from the origin to A. Okay, so it means that will give me OA. That's the vector OA. And again, okay, the origin to the point B will give me the vector OB. Do you agree? Hello, do you agree?
Yes.
Okay, so you know OA has a special notation A tilde. OB has a special notation B tilde. Are we all fine? My professors, are we fine? Okay, I'm walking you through how we got this. So that once you know it, relating it, okay, or relating to this will be very easy for you. So this is what we have. Thankfully, we've done resultant vectors. Okay, now this is the point. You are moving from the point A to the point B. Okay, but because we said we are looking at a free vector in terms of position vectors, okay, then it means we have to introduce the origin. The origin must be critical, or is very critical in trying to drum home the point, okay, that every free vector can be expressed as a position vector. Because all position vectors, you know, they take their source from which points? The whole class. All position vectors, okay, take their source or start from which point?
The origin.
The
The
origin.
origin, which is
Then
O. Is that not it?
Origin.
Okay, so it means here I've introduced another point, which is O, the origin. So if I want to move from A to O, so A to B, forgive me, because that's the direction. I can move from A to O, then O to B. I'll still move from A to B. Do you agree?
Please come again.
Okay, if I want to move from A to B, okay, now no, I'm dealing with position vector. So it means anytime I'm moving, O should be in play. So I can move from A to O, which O is in play, then O to B. Do you agree? Then in that
yes,
case,
sir.
Yes,
I've
please.
still moved from A to B. Is that not it? Only that I took another point. I didn't move from A to B directly.
Yes,
I
please.
went through O because of the simple reason that I did. So if I have there, I can say that my vector AB, okay, will be equal to, no, we move from A to O, so AO, okay, then plus what? O to B. Do you agree?
Yes, please.
Okay, now let's see the direction of the arrows. If you look at A to O, okay, are you in the same direction of your vector, okay, that you have here? Are you in the same direction? Hello, my professors, are you? From
Yes.
A to O, I look at the direction of the arrow. Are you in the same direction, A to O?
Yes.
No, you are not. Look at the direction of the arrow here. The arrow is moving from O to A, but you are now moving from A to O. So you are not in the same direction. You are opposing the direction. Please, are you with me?
Yes, please.
Okay, so if you know that if you have O to A and you want to get AO or A to O, it will be the negation of your original direction, which is what? O to A. My professors, are you with me?
Yes,
Yes,
please.
please.
Should I come again or it's fine?
Please come again.
Okay, all right. So I didn't say anything special, my prof. All right, so I said you can see that originally we've given okay the lines that we have here directions. We said O to A will give us the vector OA, that's the position vector. O to B will give us the vector OB, the position vector, etc. Then we are moving from A to B. But you have to do A to O, then O to B before you can move from A to B, passing through O. Is that clear? So that's what I've stated here. I'll move from this to this, then plus this to this. But if you look at, I said you move from A to O, but A to O is opposing the direction. Remember, this is the directional. I've given the lines directions. That's why we are dealing with vectors. Okay, so A to O is opposing the direction OA. So it becomes minus OA. Then O to B, is it in the same direction or is opposing the original direction?
It's in the same
So
direction.
it means that you keep it as plus OB. Is that clear?
Yes, please.
Okay, but you know in maths, if you have a positive, okay, you write a positive first followed by the negative. So this vector is positive, so that will give you okay vector OB, then minus what vector OA. Okay, so that's what we have here. So it means anytime you have a free vector, I know you know this because we've used it, okay, I think prior to this. Okay, only that I'm now showing you how we got that. I told you that anytime you have a free vector and you want to move from free vector to position vector, it will always be the position vector of the terminal point, okay, minus the position vector of the initial point. That's what we have here. And this is exactly how, okay, this, okay, came about. Is my point well made?
Yes, please.
Okay, so in the same way, if I have the vector BC, okay, I know that it will be the position. It will not be, please take note. Oh, if you go and write AB, okay, is equal to B minus C, you are wrong. Are you with me?
Yes, please.
This side is a vector, but this side is not. This is scalar, this is scalar, a point. So it will be OB rather minus, oh, sorry, this one is OA. I needed A, not C, forgive me. Then it will be OA. So take note of that. All right, so in this case, this will give you OC minus OB, your terminal minus initial position vector. So CD will give us likewise. CD, the whole class,
OD minus OC.
minus OC.
OD.
Okay, don't forget the arrow. Okay, when you say OC, OD, I know the arrow, okay, must be indicated. Okay, so otherwise you say vector OD, vector OC. Okay, so in the same way, PQ vector will be OQ vector minus OP vector. QR vector will be OR vector minus OQ vector. So on that note, the last one, RS vector will be
OS minus
OS vector minus
OR.
OR vector. My professors, I guess we are all fine now. Okay, so, and you agree
Yes,
with me that
please.
we've been using this. Okay, prior to today's, we've been using this. So now you know where, okay, that came from. Okay, so you wouldn't get it twisted anytime you are asked to, okay, deal with anything of this sort. Move, okay, from free vectors towards position vectors. You should know how to deal with that. Okay, so let's move on to the next okay, slide. But before that, are we all fine, my professors? Hello, my professors, are you all fine?
Yes,
Yes,
please.
please.
Okay, all right, we thank God. So now let me see. Okay, we are not within the 1 hour for us to have. So let's continue. Okay, so we are going to look at what the midpoint. I think I left this one out when I was stating the objectives. Okay, I only talked about point to vectors, free vectors to position vectors, then okay, magnitude bearing to column and vice versa. Okay, however, we are going to look at the midpoint theorem as well. Okay, the midpoint theorem is basically under a broader theorem, which is what the division, okay, theorem. Okay, the division theorem. However, I'm going to bring out only the special theorem connecting that, which is the midpoint theorem. So we are going to look at the midpoint of a vector. We know how to find the midpoint of a line segment, which is not directed. Okay, the same concept that we are going to use to deal with was a midpoint of a line segment that is directed, and that is what a vector. Okay, so quickly, if A, the point A, and B are position vectors of the point, so that is a point A, forgive me, A tilde and B tilde, or the vector A and the vector B, you know they are small letters in bold, so you know by now, you should know what that represents. Are the position vectors of the point A and B. And even if I didn't write this, you should know that this is a position vector of the point A, this is also a position vector of the point B, you should know as well, respectively. And M is the midpoint of the line segment AB. Then the position vector of M. So you know that the position vector of M will be, if A is the position vector of A and small b is the position vector of B, then position vector of M will be small m. Right? It will be M tilde when you are writing it. Is that clear?
Yes, please.
Okay, so it's half of what? So you sum what? Your two vectors. Okay, and you divide by 2. So it's the same concept. If I give you, okay, the point, if you are dealing with a point, Prof. Bliss, hold on. Okay, I'm coming. If you are dealing with a point 2, 3, okay, and that's point A, and the point B to be maybe 4, okay, let me do 4, 9. And I ask you to find the midpoint of the line joining AB, what will you do? Wouldn't you do half of what? The sum of the x coordinates over 2, then the sum of the y coordinates over 2. Is that not what you do?
Yes, please.
Is that what you do?
No, please.
No, it will be, this will be up. It will be sum of over 2 over 2. This should be, if immediately you bring this, then it becomes the sum of the x coordinate, the sum of the y coordinate. You don't bring this. So be very careful of what I say. In math, whatever that you say, okay, might carry another meaning. I hope you are with me now, Prof. Aduma.
Oh, yes, please.
Okay, all right. Okay, so at this point, you know it will be half of the, so let me go, half of what? The x sub 1 plus y, x sub 2, okay, then comma, sorry, then y sub 1 plus y sub 2. But usually I advise you not to write it this way. Instead, write this over 2, this over 2. If you remember when I taught you the coordinate geometry 1. Okay, so you can see that it's half of the sum of your point. So in this case, it will be half of the sum of what? The position vectors of the point. As simple as that. It will not be minus. So usually we don't encourage students to write half. If you write half of AB, okay, you should be careful you don't use, okay, the position vector form of this to represent, I mean, of AB to represent the expression AB. Other than that, you get half of what? OB minus OA. Do you agree with me? If you use the direct meaning of what? Of AB in terms of position vectors, which will be wrong. Because you know that subtraction is not commutative. I hope you get my point. Should I come again, or my professors? My point is well made. Prof. Blaze, you can come in now.
Sir, please, I don't get the A plus B. Isn't the A is position vector?
Yes, it's a position vector. So you know
So
what?
will it
I'll
be
define the A and B here.
O A plus? So sir,
O
please, is
OA, will
the
it be what?
A
OA?
O is A O A and B is O B?
Are you saying or you are asking?
Sir, I'm confused because
Okay, don't be. Okay, by now you should know. Okay, if you have OA, what's the special notation for OA?
sir, please, A tilde.
Okay, and A tilde, that is when you are writing it. Is that not it? However, when it is
Yes,
typed,
please.
which will be when it is okay in print, how would you see the A? How would you represent? How would this be represented? If you want to write a special form of the vector OA, how would you do when you are typing? Or how would you recognize that in print?
Uh,
When you are writing the A, you write A tilde, but in print, what did I say? Okay, how would it appear?
Bold.
this small a.
Just small A. Then it means you need to do revision. All right, because I told you that in print it will be in
In
bold.
bold.
So why should you be confused? You know the way I teach. Okay, I try and build your concept. So anything that I at least I've given you prior knowledge, information regarding that. So your A here, is it not bold to you? This A and this A, are they the same? These two A's that you see, are they the same? You can say that this is A, but it's not bold. This is A, is bold. I hope you get the point. So it means this is a vector, and this is also a vector. And even you've been told here, even if I didn't write A bold and B bold, and I wrote A, B, you are told that they are position vectors. So you know that A is a vector, B is a vector. You get it? Hello, my professors, are you with me? Especially Prof. Blaise, are you with me? Okay, so simply put, your A and B here, they are all vectors. That's why we say they are position vectors of what. So it means invariably, okay, or you can write exactly what we have here also to be the same as what. Okay, this is the same. I can write maybe my small m tilde, okay, is equal to half of what? A tilde plus B tilde. That's when you are writing it. Okay, or I can come and say that let me clear this once it has served its purpose. Okay, or if I don't want to use the special notation for my position vectors, I can write, okay, OM vector, okay, will be equal to half of, okay, OA vector plus OB vector. I hope you agree with me. My professors, I hope you agree with me.
Yes, please.
Okay, so there's the special notation form on top. Okay, and this one is the usual notation. Okay, the notation using 2 points. All correct? Prof. Blaise, are you here?
Yes.
Okay, you get it
was,
now.
yeah, my question was that can we write it in the second way you wrote it?
And my answer was that you should know that we can write it in this form. You get it? You did a special notation form. I've been saying this times with a number. You get it? This is the special notation form. If you don't want to use the special notation form and you want to use this, you can write it because they are the same. Okay, so in the earlier, I was trying to say that I should have taken your question as a rhetorical one. You get the point? All right. Okay, so that's it. So if you are using a special notation, but you cannot write this, take note. You can write M is equal to half of, okay, either A tilde plus B tilde or OA vector plus OB vector. Is this a vector? Hello, is it a vector?
Oh, please.
Okay, so this is not a vector. So it means this side, a vector here should be equal to a vector here. So this should rather be either OM, okay, or M tilde. Afa,
Yes, please.
Okay, very good. So take notes of how to use your notation and use them well. Okay, all right. Okay, so now that you are okay with this, okay, let's go and look at one or two examples. Okay, especially under the midpoint, okay, theory. All right. Okay, so let's see. Given that the point A, 3, 2, the point B, so these are the points. You've been given 4 points, A, B, C, D. Find the midpoint of, okay, and you can see that this, what you have here, okay, is a vector, a vector, a vector, a vector. So all of them, you are finding midpoint of a vector. So if the midpoint of a line is a point, the midpoint of a vector will be a vector. Is that clear?
Yes, please.
Okay, so take note of this. Once you have this at your fingertips, okay, the rest of whatever that we are going to do will be easy because you know how to add vectors and you know how to multiply a vector by a scalar. That's basically all that we are going to do. Okay, so in this case, what do we write? We are going to extract. So it will be given, solution is what you write first. Given, then you extract. Okay, we're given points. So you extract your information in the point form. So A is equal to 3, 2. Okay, B is equal to, I'll extract the first two just because of time. Okay, that is what? 5, negative 8. Okay, then, okay, the rest. I'm representing the rest by ellipses. That is the C and D. Is that clear?
Yes, please.
Okay, so at this point, before you even come and write the given this, you know that you are going to deal with vectors. And I've told you, anytime you are given points, which will be in the coordinate form, and you know that you are going to work with vectors, what did I say you should do? What was the advice? Anyone to make us proud?
Please, can you ask the question
I
again?
said, anytime you are dealing with a vector question, and in the vector question, you have points given. Okay, what did I say you should do to the point? After extracting the point, what did I say you should do before you go and find whatever vector that you are supposed to find? I gave you a very simple advice. My professors, are you there?
Yes, please.
Okay, Prof. Ella, Emanuela.
So you first have to change them into vectors by adding OO to each of them
As
and bringing
simple
the
as
vector
that.
sign.
As simple as that. Thank you very much, Prof. Emanuela. As simple as that. And you know, even today, what we've been doing, because you know that you are going to deal with vectors. Okay, every point you know is a vector, but it's a position vector. What we did today extensively today. So that's why I said previously we've been using that concept. So you have a fair idea, but maybe you didn't know where that was coming from. And today you've learned that. Okay, so you are stronger today. You are not just going to, so you know you are going to deal with vectors. So it means every point that you are giving there, you write its vector representation. So that would be, this implies that every point is a position vector. So your OA, if you want to use OA, you can use OA. If you want to use the special notation, you use the special notation. Is my point well made? Okay, so I am going to use OA. Someone can use a tilde, a small a tilde, it's the same thing. Okay, so it means you want to use the special notation, position vector notation. I don't want to. So, and in that case, can I write 3, 2 in row? How do I write it? In column, right?
Yes, please.
Okay, so comma, then OB, the vector OB will be equal to also in row. So in column, forgive me, 5, negative what? 8. Okay, then you go to your vector OC, okay, which will be equal to also in columns will be, okay, minus 1, 3. Okay, and the last one, OD. The vector OD will be equal to minus 4, okay, minus 3. My professors, I hope you are following. So as for this maths, we shouldn't lose it. Okay, moving from point to vectors, Okay, because you know, if the question says, okay, given the position vector of the point, then it means you start straight away by writing given OA, OB, you don't extract it in the point form. But here we're not told that. We're told directly that these are points. We didn't say that they are position vectors of certain points. So you extract it as a point first before you come to the position vectors. Is that clear? So get to note of the difference. So at this point, okay, let's do the A. A, what are we looking for? We are looking for midpoint of what? Midpoint of what? Of the vector AB. Am I right?
Yes, please.
Okay, and you know I'm not going to represent the midpoint by any letter. So I'm still going to look at the midpoint of AB. And we know that that would be equal to half the formula. It has a formula. Half of what? The position vector of the point A, then the plus the position vector of the point B. So because I am using not the special notation, but this one, that's what I'm going to quote here. I'm going to quote, okay, Bless's, okay, own. So that will give me, it will be half of what? Vector OA plus vector OB. Is that clear, my professors?
No, please.
Okay, so where lies the problem?
Please, mostly when you're starting your work, you write A there for midpoint of AB. So I'm wondering why it didn't come.
Okay, he said mostly.
Yeah.
Okay, so it means you didn't say usually, or you didn't say always. So if it is mostly and I don't write it, then it means I can equally write it that way. But I was going to add it anyway, that once you know you are going to conclude with this, you can write therefore. So that's why the space is here. Okay, but before you conclude, you should know exactly what to do. So I'm not representing my midpoint by anything. So if you represented your midpoint by maybe, so you write M tilde or OM, you cannot conclude with OM because we're not told that the midpoint is M. Take note. So thank you very much anyway. So that will give us half of what? Your vector, so your vector OA plus what? Your vector OB. Okay, so what is your vector OA? You know that is 3, 2. My professors, I hope you are following. OB is 5, negative 8. Okay, so we come and deal with what we have in brackets first. So once you deal with what you have in brackets, okay, the outer bracket will take the form of the inner bracket. So half of what? 3 plus 5 is what? 8. Okay, 2, is it 2? Yes, 2 plus minus 8 will give us what? Minus 6. All correct, my professors. Prof. Adoma, you said I didn't answer your question. I did. I said you can write therefore here or choose not to. In that case, you draw your conclusion later. Okay, but I would write therefore going forward.
Yes, please.
Okay, all right. So in this case, this will give us, okay, we know now how to multiply a scalar and a vector. So let's go. So that will give us half, okay, times 8, which will give us 4. That is 8 over 2. Then half times minus 6, that will give us minus 6 over 2, so minus 3. Okay, so therefore the midpoint of your vector AB will be what you have here. And indeed, your midpoint of the vector AB is a vector. Okay, if we're asked to find the midpoint of AB, okay, with no arrow on top, or even, line, directed line, or just a line with no direction, okay, you know that you state it in the row, or in the row form because of the way you write it, not in the column form. That's not to say that if you write it in the column form, you mark you down. Okay, points can be expressed in the row or column form. Only that vectors are usually expressed in the column form, not row. All correct. My professor says my point well made. We are going to do one more. Okay, then after that, that will be the rest. We have more examples here. And I've told you, initially, okay, when I started teaching you, I was solving, Okay, more, I usually solve more examples, but you know, this particular time, okay, time is of great essence here. We need to cover. Okay, so immediately I teach one or two examples and you are okay. You have the other examples there. You can try it. You don't have to come and solve everything in class. Meanwhile, you have a lot to cover unless you didn't understand. If you have understood, why don't you, okay, do the rest of the questions on your own? Okay, so that's the more reason why we are not solving more questions as we usually do. But I'll make sure you are not deficient. I'll pick the questions that after solving, you should be fine to deal with the rest. Okay, so let's go to AC. So midpoint of AC. So at this point, I know it will be midpoint is equal to, so I'll start by writing therefore. Okay, so therefore midpoint of which vector? Vector, let me do AD. Okay, I've written B here, so let's do AC. Okay, AC. Okay, will be equal to, you come down, or you write equal to, then later you come down. So that will be equal to half of what? The position vector of your first point plus the position vector of your second point. So it will be half of what? OA, okay, plus OC. Okay, which is the same as A tilde, okay, plus C tilde, half of that. But we are not using the special notation. So this will be equal to half of, you know that this will be column. Okay, this will also be in column. It will be in bracket. So I will change my outer bracket. If you like, you can use the ordinary bracket and come and do this. Okay, plus this. Only that the right thing is to use the square bracket. Okay, because inner brackets, if it's ordinary, outer bracket must be square. But I just want you to know that if you write it this way, you are not wrong. Only that this is the right way. Okay, so now that will give us OA. The same our OA, which is 3, 2. Okay, then OC. OC here is minus 1. Okay, 3. Okay, so at this point, this will be equal to half of. You are now going to work with what you have in bracket. You combine. And as you combine, it will give you one bracket. So the outer bracket will not be necessary. So that will give you 3 plus minus 1. That's positive 2. 2 plus 3, that will give us what? 5. So it means we are going to get this on 2 or half times 2, which will give us 1, then 5 over 2. So that will give you 5 over 2. Okay. If you like, just like I told you when we were doing the coordinate geometry, I said in the Cartesian plane, if you don't change your answers to mixed, okay, numbers, it's allowed. You can conclude with an improper, okay, fraction. However, I just want to be consistent. Okay, so that, okay, that will give us, you change, so it will be 2 whole number, 1 over what? Over 2. Point well made. But if you end here, you get the full score anyway, because there's a special situation. Okay. My professors, are we all fine? It's my point well made.
Yes, please.
Okay, very good. Okay, Prof. Amma, you've been able to join, and you didn't indicate that on the platform.
Oh, sorry. Say.
Uh, uh, you need to indicate that. Okay, when you were not able to, you told us if you've been able to, you have to go on anyway.
Sir, please, I'm confused. Sir, please, have you seen the general formula for a midpoint to have in
Were
bracket?
you with us from the beginning?
No, but I was there when you were teaching the midpoint. I was
Okay,
around 20.
you were here. Okay.
Yes, sir, please see the general formula for midpoint is half into bracket x, comma, y. So I wanted to ask why this formula it is plus and not y and not comma.
Which one is? Is it this
The
one?
formula is the midpoint of
Okay.
this
So you
vector.
can see that the one that we did, comma, x plus y over 2, sorry, x1, y plus x2 over 2, okay, comma, then y. That one, you were writing it in the row form. So the first one is just a coordinate, x coordinate. The second one will be the y coordinate of your point. Is that not it? Only that you were
Yes.
finding the average of the x coordinate and the average of the y coordinate. Is that not it?
Yes, please.
Okay, so on that note, if you write a comma here, you can see that every vector, okay, that you have here, this will contain the s component and the y component. And you are not writing it in the column form, sorry, in the row form. You are writing it in the column form. So if you come and write comma here, assuming this is comma, okay, so you end up getting what? 3, 2, okay, comma, 5 minus 8. What is the meaning of this? You
It
mean,
has no meaning.
so you are trying to say that this is the s component, this is the y component. Meanwhile, this s component contains y component as well. This, what you are assuming to be your y component, contains s component as well.
Oh, okay, I can see it now.
Okay, all right. Okay. Even with the point 1, it's the same thing. Okay, with the point 1, it will be half of your a plus b, not a comma b.
Okay.
You get it?
Yes, please.
All right. Okay. Only that here you are dealing with vectors, so the O becomes OA, B becomes OB. That's all.
Okay, sir.
All right. Okay. So I've told you, ask questions. When you ask questions, I'll always have ways that I can explain for you to understand, because I mean, by the grace of God, I'm very solid. Okay. All right. Okay. So on this note, okay, we are going to end here. When we come back from our water break, this will be an assignment to come later. When you come back from the water break, make sure you come with your calculator. So let's have 5 minutes water break. By 11:10, we should all be back. Hello, welcome back from the water break. Okay, so quickly, let's look at our next concept. Okay, and we are going to look at expressing column vectors as magnitude and bearing vectors. So that is converting vectors in the column form, okay, to the magnitude bearing form. Okay, here, as for how to find the magnitude, so it means the vectors will come in the column form. So you know the s component, the y component, and we all know we've done finding the magnitude of what? A vector. Prof. Olali.
So please, I can't hear you clearly.
At everybody's end.
I think your voice is like kind of back.
Okay, all right. So is it clear now? Is it better?
Yes,
Yes,
it's
yes,
loud
please.
now.
Hey, all right. Okay, so very good. Okay, so if you can hear me now, that is okay. It's good you had my attention drawn to that. Okay, so at this point, this is what we are going to do. Okay, like I was saying, we are going to look at a situation where you are given vectors in the column form or the component form, and you are asked to move, such vectors to the magnitude bearing form. So it means you need to find the magnitude of the vector, because we need the magnitude and the bearing. And we are all experts in finding the magnitude of vectors, especially if it comes in the column form. The relative math student, they know that of the Cartesian form as well, how to find that. Then, how to find the bearing, of a vector given in the column form. And the main challenge here, which shouldn't be a problem going forward, will be the bearing aspect. As for the magnitude bearing, the magnitude, we have done that. So I will be more particular about what the bearing, or will concentrate more on what the bearing, going forward. However, this is it. So assuming we said case 1, when both x and y components are positive. So by that, this is what I mean. Assuming I have a vector, so let me use a free vector AB. In the column form, it will be xy. General x component, general y component. So if I write xy, then it means I'm taking my x to be positive, my y to be positive. So here it satisfies the condition there. Your x is positive, your y is positive. So if I want to find the magnitude of this vector, I will say that magnitude of vector AB, and we all know, will be equal to root of what? x squared plus y squared. All correct. Hello, my professors, are you with me?
Yes, please.
Yes,
Okay,
please.
we are dealing with generals now. You can see that I picked a general vector xy. X could be any value, y could be any value. Okay, but I'm saying that if your x and y are values, they should give us only positive values. Only positive values for x, only positive values for y. So you know how to find. If you know the exact x and the exact y, then you know the exact. So it means whatever that we have here, unit, that will be the magnitude, which we are expert. And I've said, okay, we are not here, okay, more because of what the magnitude, but we are here, okay, because of what the bearing. Now let's go and look at the bearing. Okay, remember, I told you that anytime you are going to find a bearing, you need to draw your diagram. I mean, you need to indicate your Cartesian plane or your cardinal point, which will basically come from your Cartesian plane anyway. So I will have my y axis and my x. Okay, my y will double as what? My north. Because in bearing, we said angles are measured, okay, from the true north. Okay, in the clockwise sense, clockwise direction. So one of my lines forming the angle, okay, will be my true north line, which is what we have here. Okay, now we said our vector xy, AB, the vector AB with the component xy. The x component is positive, the y component is positive. So it means my vector is located in this quadrant. Do you agree?
Yes, please.
Okay, so assuming I'm talking about my vector, it means my initial point will be A. Let me use A here. So it's no more the origin. And my terminal point is what? Is B. So it means this will be B. So it means I'm looking at the vector AB here. All correct, my professors?
Yes, please.
Okay. Now take note. Remember we said angles are measured between two lines. In terms of bearing, your angles are measured between the true north and your vector. Take note, true north and your vector. So one of the lines will be a baseline, which is your true north line. The other line will be where your vector is. So it means the bearing angle that I'm looking for is this angle. All correct. Hello, are you with me?
Please come again.
Okay, the bearing angle we said is measured from the true north. Bearing angles are formed between two lines. So one of the lines will be your vector, and the automatic line will also be, okay, your true north. This is your true north line. Is that not it? This is your south line, your west, and your east. So your bearing angle must be between your true north, okay, true north, okay, and your vector. All correct. But in which direction? In the clockwise direction. So this is my true north. I measure clockwise up to my vector. So that's why you can see the direction of this in this sense. So it means I'm looking for this angle here as my bearing. But you know, if you are dealing with your vector, before you move from A to B, you go from here to here. So the movement here will be your X, and the movement here will be your Y. Do you agree? And this will always be a 90 degrees, okay, angle. So you always have a right angle triangle to deal with. So if the angle here is theta, okay, you know your x, your y. So you can find theta here. Once you know theta, you know this is subtracted from what? From 90. So in this case, your bearing, okay, and usually it will be the bearing of what? Your terminal point from your initial point. So the bearing of, okay, B from A, okay, will be equal to, okay, and usually bearing will be, okay, you will know that you are finding the bearing of B from A. Our next topic likely will be bearing in 4. Okay, so it will be your angle, your entire angle here, okay, will be 90. So if I know this angle, I know this angle. So it means my bearing angle will be 90 degrees minus theta. Do you agree? Should I come again, my professors?
Yes, please.
Okay, all right. So this one, it shouldn't be a problem. Know your two lines forming your angles. And your two lines, I said, okay, your true north line and your vector. But the angle must be measured in the clockwise sense. Otherwise, you can see between these two lines, if let's say I have my true north, I have my vector. Okay, I have two angles formed. One is here and one is here. Do you agree? Anytime two lines meet, two angles are formed. I hope you agree with me.
Yes, please.
But we said the angle that we are interested in will be the angle measured, okay, in the clockwise sense from the true north. So this is your true north. Okay, clockwise sense will be here up to this. So we are looking for this angle, not this angle. The angle moving in this direction. So this is the angle. So if let's say I call this angle alpha, I know that, okay, alpha plus theta, okay, should be equal to 90. Am I right? Alpha is my bearing angle. So alpha will be equal to what? Okay, let me call theta. Alpha will be equal to 90 degrees minus theta. Do you agree?
Yes, please.
And what is alpha represent? Is it not your bearing angle?
Yes, please.
Okay. So if you know theta, you just subtract it from 90 and you know your bearing. However, you know that you can easily find theta by using the appropriate trig ratio. In this right angle triangle, opposite is known, adjacent is known. So it means here, we'll say that but, okay, theta, so let me write tan theta, will be equal to opposite, which is y over x. Remember, these will be values going forward. So it means theta will be equal to tan inverse of y over x, which we can use our calculator to do, knowing the values of x and y. So it means theta will be known. And once you know theta, you come and subtract it from the 90 degrees and you will get your bearing. So it means if your vector lies in the first quadrant, that is when the x component of the vector and the y component of the vector is positive, your bearing will be, angle will be given by 90 minus what, theta, 90 degrees minus theta. Take note of that. Is my point well made? Hello, is my point well made?
Yes, please.
Okay, now
Yes.
let's look for, because your vector can also be here, it can be here, it can be in this quadrant. So each quadrant and how to find, okay, the bearing. So we now know that of the first quadrant, of this quadrant. Let's go and look at the other quadrant too and see. So case 2, okay, the second situation, when the x component is positive and your y component is negative. So it means this time round, this will be your AB vector. Okay, I have x, y. But remember we said the x component is positive and the y component is negative. So it will be negative y. Is that clear?
Yes, please.
Okay. My professors, I hope you are following. Please, if you don't get anything, let me know. This is the most technical aspect of the vectors, how to find the bearing. Okay, and it's very easy. It's technical, but very, very easy. Okay, and I'll try as much as possible as I've been doing to break it down, provided you ask the necessary questions as well. So this is what we have. So in the same way, if we are finding the magnitude, you can see that it will be the same thing. The magnitude of the vector AB will be equal to root of, this time around it will be x squared, okay, plus minus y squared. Do you agree? But it will be the same thing. Do you agree? Because this will still give you y squared. So as for the magnitude, we are expert. So I don't think I should, okay, belabor the point here. My professors, are you with me? So let's go and look at the vector. So the bearing. So again, your true north. Okay, then your x and y. Okay, so let me maybe indicate my y, my x. So in this case, this is what we have. Okay, if your x component is what, positive, it means you move x places on the or to the right. Remember when I took you through the component form, I told you this. So this movement here will be x. Okay, then y component is negative. Do I have to go up or I come down?
Come down.
Down. Okay, so I come down. Okay, however, how many spaces? Y spaces. Is that clear? So I move from here and ended here. So it means this will be where my vector AB is, where AB will be. So this is the vector AB. Do you agree? Let me indicate my arrow on top. Is my point well made?
Yes, please.
Okay, so your vector AB, you know there is a right angle triangle here. So this is theta. Let me call, okay, the angle here theta. So in this case, you know, bearing the angle will be measured from the true north, this line, up to where you have your vector. So my bearing angle will be from here up to where I have my vector, which is this. Do you agree? My professors, are you with me? Who wants me to come
Yes.
again? Okay, we said angles are measured between, in terms of bearing, angles are measured between two angles. Two lines, forgive me. Okay, what are the lines? From Blaze.
True not line.
And
I don't remember the second one.
and the vector line. Okay, so if I got you right. Okay, all right. So your what do you call it? Line, or your voice was muffled. Okay, so in this case, this is what we have. Okay, so it is from this. So it means if I know the angle here, I know the bearing. But the angle here, from here up to here, is 90. Do you agree?
Yes,
Okay, so can I say that my bearing, and in this case, it will also be the bearing of B from A, will be equal to 90 degrees, okay, plus this angle here, which I'm referring to as theta. Do you agree?
yes, please.
Okay, so you agree. And we know how to find theta. Theta will always be, okay, so if you want to find theta, it will always be but, okay, tan theta. Okay, this will also be opposite of adjacent. It will always be opposite to this is y, and this is x. So it will always be y on x. So what we have here, you get theta to also be equal to tan inverse of what? Of y on what? On x. So once you know your theta, you come and add it to 90, and that will give you your bearing. Remember, theta is not the bearing. Is my point well made, my professors?
Yes, sir.
Okay,
Yes.
very good. So now two more cases. We've dealt with if the vector is in this quadrant, the first quadrant, now the fourth quadrant. I'm moving in this direction. So this becomes the third quadrant. So yes, and the second quadrant. So let's go to the next one. Case 3. When both x and y, okay, components are negative. So it means here again I have vector AB is equal to x component is negative. So negative x. Y component is negative, negative y. Is my point well made? Okay, so if you have this situation, yes, please.
Please, the previous slide, the one we just passed, was the point B, will it be where what's this? Just below the 90 degrees, the point below.
Which point below?
Which point? I don't know how to describe it, like the origin. And point B is the one at.
So this is where you started. Where you started will be your A. Where you ended will be your B. So that's why it's AB, the line AB.
So I don't know.
So I'm explaining, assuming I have understood. Your line is breaking. So try and follow. If that's what I'm saying is exactly what you mean, okay, you take it. If not, then you come again because your line is breaking. I'm just trying to connect. So this is where your vector AB is. So it means this is your A, this is your B. I've indicated a vector. So where you started is your A, where you started is your B. So this is your vector AB. That's why I've given this line a direction. Is that clear? So this vector here, let me see if I can correct.
Yes, please.
So this vector
And
here is
sir,
AB.
please, the last.
Mm-hmm.
Sir,
Please.
please, the last question. Will the bearing always be from? Will it always be bearing of B from A, or it will change as the
No, when you
values of the
please take
X
notes.
and
Take
Y
notes.
component
I'm sorry, I won't even allow you to land. Your vector here is AB. So it means all that you are doing, the reference point is A. So if you are taking your distance, the distance from A to B, that's the direction. If you are taking your bearing, it will be your bearing of B from A. So all of them, your reference point is A. If I give you B a vector, okay, it means your reference point of this vector is B. Anything that you are doing is related to B. So if you are finding the bearing, it will be the bearing of A from B. That is the meaning. It will always be from your starting point, as simple as that. I've said we'll do bearing in its own, but get the basic concept that I'm throwing to you or throwing at you, okay, in terms of whatever that we are doing here. We'll do bearing proper. So here, I just want you to know how to locate your bearing angles. That's all. Basically, that's what I'm doing here. Okay, all right. So now this is it. So the third one, this is what we have. The third case, we said the S component is negative. So I'll move from here, move X units, okay, or S spaces to the left because it is negative. So it means from here to here, assuming this is where I ended. So this will be my X. Do you agree? Hello, do you agree? And why? Do you go down or up? Why is negative? Do you go up or down? My professors, can you hear me? Do you go up or down?
Down.
Down. Okay, so you move down. How many units? Y units or Y spaces? So this will be Y. Okay, so it means I started from here and ended here. So my vector will be here, will be this way. And what will be the vector? I started from, I'm looking at the vector AB. So it will be AB vector. Okay, so it means this is looking at the direction. My A will be here and my B will be here, basically. Safa. So I've told you this will always be 90. Don't forget to indicate 90. So this will then be your theta. The theta will always be, okay, the angle between your vector in that quadrant and the x-axis of that quadrant. The theta will always be that angle. So it means here, my true north is this. If I'm finding the bearing will be the angle between your true north, okay, in the clockwise direction up to where you have your vector. So from here up to where I have my vector. Is that clear now? Is it clear? So I won't talk about the magnitude. You know the magnitude, how to find it is very easy. Okay, so I'm straight away moving on to the bearing. So the bearing here will be equal to, remember it is from here up to here. Somebody can do 90 plus 90, which is 180. You know your theta, subtract theta from 90 and come, but I wouldn't advise you to do so. You know from here up to this line is 270. Do you agree? From here up to, let me change my, I think that is not clear. So let me go for it. Okay, so from here up to this line, okay, is 270. Do you agree?
Yes, please.
So it means if I subtract theta from 270, I will get the bearing from here to here. Do you get it?
Yes, please.
So I can comfortably come and write that my bearing will be equal to 270 degrees, okay, minus theta. And again, but your theta, tan theta, okay, will be equal to what? Y over x. So in the same way, your theta will be equal to tan inverse of what? Y on x. Is my point well made? So you know, use your calculator to find the theta, then you go and subtract it from 270, and that will give you your bearing. How far?
Yes, please.
Okay, very good. Now the last one. Okay, so that will be in the second quadrant. So again, if your vector AB, if my vector AB, the x component is negative, so it means I will have negative x. And my y component is positive, so positive y. In this case, it means this is my y, this is my x, my y doubles as what? My true north. So we said negative x means I will move, okay, in this direction, remember. So how many units? X units. Okay, then positive y means I need to move down. Am I right? Do I have to move
No.
down or up? Positive y.
Up.
Up. Remember, down is negative, up is positive. So I will move up, okay, y units. So positive y units. Okay, and it means I move from here to here, then here to here. So this will be my vector. Okay, so my vector here will now be AB. The same vector AB. Remember, that's what I'm dealing with. Okay, this will be 90. The angle between the vector and the x-axis of that quadrant will be what you call theta. Okay, but you know that your bearing will be from here up to where your theta, your vector is, so up to this. Okay, so that's the bearing angle. So in this case, okay, as for the magnitude, you know, root of minus x squared plus y squared, we know. So bearing angle will be equal to what? In this case, you can see that from here up to here is 270. So if I know theta, I add it to 270, and that will give me the entire angle here. Is that clear? So that will give me 270 degrees, okay, plus theta. And again, okay, you know how to find your theta. So that's, okay, tan theta, opposite of adjacent. And take note, your triangle that we have here, all the values that you are going to state here will all be positive. The negative will tell you which direction to move. So the negative here in the components, okay, will tell you the direction. But when you are stating this, you don't write negative x here. Take note, I never did that. Negative y, negative x. So but tan theta, okay, will be equal to, okay, y over x. So it means theta will be equal to tan inverse of what? Y over x. And once you know that, you are good to go. So with that, okay, let's go and look at how to make use of what? The concept that we just learned to deal with this question. So maximum attention, my professors, at this point. Okay, you realize that it is very easy. Okay, to be very, very easy. Okay, so now let's go. All right, so let me see quickly. I want to do something because I think going forward I will need it. So I don't want to use my free hand. So let me pause and do something quickly. Okay, so quickly let's look at the solution to, so what are we? Express the following as magnitude bearing vectors. So vectors in the magnitude bearing form. So until you get the magnitude and the bearing, so until you write it in the form, okay, so you know it will be in the form, magnitude bearing form. When I was taking you through the types or the forms of vectors, I said it will be your bearing, okay, your magnitude of the vector, okay, then bearing, then you put it. That's how you write it. Okay, so quickly, let's see. A, what are we given? So you've underlined the salient part. We've been given the vector AB. Okay, so that is equal to 3, 4. My professors, are you there?
Yes, please.
Okay, so we need the magnitude and the bearing. We are magnitude experts. So let's go and find the magnitude first. So this implies that AB magnitude, vector AB magnitude, I know will be equal to the x component squared, which is 3 squared. Okay, plus the y component squared, which is 4 squared. Okay, we are experts now, which will be equal to root of what? Oops. Okay, 9 plus 16, which will give us root of what? 25, which will give us 5 units. Am I right? Is my point well made?
Yes.
Okay, so we are done. We know the magnitude. Okay, but it's left with the bearing. Then we are now comfortable to state the magnitude bearing form of this. So we know that we have to go and find the bearing. Bearing, we need the diagram. So that's the more reason why you don't leave any space in the same question. Okay, so don't leave any space. I'm not moving from a sub question to. And so the bearing, let's look at the nature of the vector. X component is 3, so positive 3. You move positive 3 units on the, so this will be your X axis, your Y axis, and your true north. Okay, 3 units here. All right, so this will be 3. Then you move 4 units up. Am I right? So it means this will be 4.
Yes, please.
Okay, so from here to here will be what you are referring to as your vector AB. All correct, my professors.
Yes, please.
Okay, so you know that this will always give you a right angle triangle, don't forget. So if you look at this carefully, if I call this angle here theta, okay, I can see that my bearing, remember my vector is in the first quadrant. In that case, we said the bearing will be 90 degrees, which is the sum of these two angles, okay, giving us 90. So if you make this the subject, you get what? 90 minus theta. All correct. My professors, are you with me?
Yes, please.
Okay, very good. So our duty is to go and find, okay, theta. Okay, and theta we know. Once this is a right angle triangle. Once you know two of the sides, you know theta. So I'll come and write but, okay, tan theta. I know the trig ratio. I know the opposite and the adjacent. So theta will be equal to what? Opposite, which is 4, over the adjacent, which is 3. All correct.
Yes,
Okay,
please.
so it means theta, okay, will be equal to tan inverse of what? 4 on 3. Am I right? So use your calculator to do that for me. I'm waiting. What did you get? 53 points.
1301.
Okay, so
1301.
you had 53. So this is equal to 53.1301. 1301. Okay, so 1301. Okay, remember it's an angle, so don't forget your degrees. You approximated, so don't forget your 4 dp. All correct.
Yes.
Okay, so at this point, is theta the bearing?
No, please.
Okay, so the bearing will be 90 degrees minus theta. So I can say that this implies that my bearing will be equal to 90 degrees minus what? 53. Okay, 53.1301. Okay, 301 degrees. Don't forget your degrees. So that gives you
36.8699.
Okay, very good. So here you have to be very careful. In bearing, angles are usually stated in 3 digits. Your whole normal part must be 3 digits. So if you realize that you have 2 digits, then you precede that with 1 0. If you have only 1 digit, then you precede that with 2 zeros. So it means you said you had what?
036.869.
Okay, so I'm going to write that 0. Okay, you give the other one. This one, we are not drawing our conclusion. So give the one without a 0. I'll tell you something.
36.
0.8699.
8699. Okay, so don't forget its degrees. Don't forget your unit. So you are now going to draw your conclusions. So therefore, okay, the vector AB in its magnitude bearing form. What is the magnitude? We had 5 units. We don't know the units, so you write the units. Okay, and what's the bearing? The bearing, let me approximate. Okay, so here I'm approximating to the nearest whole number. So that will give us what?
37.
37 degrees. Okay, so you can see that I've indicated my approximation sign, so I don't have to indicate any approximation. So that would be 037, okay, degrees. Is that clear, my professors?
Yes.
Mr. Akron,
Yes, my prof.
please, that 37 degrees, it looks like 370.
Which one?
The approximation, the one you wrote approximately.
Okay, but you know it's 37 degrees.
I don't know.
No, but you said it. You even said that 37 degrees is looking like 370. So it means you know. You get my point.
Yes,
Uh,
please.
okay, all right. So, yes, please. So it's 37 degrees. Take note. Okay, all right. So let's move on. Can we move on to the B? Yes, please. Hello, can we move on?
Please, it looks like someone wants to ask a question.
Yes, but the hairline is bad and it keeps drawing us back. That's my worry. Okay, so let's move on. Okay, so we are moving on to B. Okay, you leave a space before you come to B. Okay, so B, what are we giving? PQ, am I right? We've been given the vector PQ, and PQ in the column form 5, negative 3. All correct. So we need the magnitude and bearing. So we know, okay, this implies that the magnitude of this vector PQ, okay, will be equal to, okay, oops, what did I do? Oops. So you are finding the magnitude, which we are experts. So I think I shouldn't have even, okay, so that will give us 5 squared, okay, plus minus 3 squared. Okay, so which will give us is equal to, here, let's go, root of 25, okay, plus 9. Okay, which gives us root of 34. It's 34, you need basic form. My professors, are you there?
Still 34, yeah.
Root of 34 will still give you root of 34. So it's in basic form. So you attach units here. Is that clear?
Yes, please.
Okay, so what is left? The bearing, is that not it?
Yes, please.
Okay, you don't leave a space. So bearing, you need to go and draw. Okay, so bearing. Fortunately, I have drawn mine here. Please, okay, you cannot use your free hand. That's the more reason why I have this. So use your straight edge. Okay, unless where you are at the moment, you don't have it. But as I exercise, what have you? Use a straight edge. Don't use your free hand. So this will be my Y, my X, then my true north. Okay, so my diagram is very critical. My S component, okay, where is it? It's positive, so it means this movement here will be positive 5. Okay, so here will be 5 positive. Okay, then I will move down, okay, negative 3. So because it's negative, it means I will move down. So the down here, this will be 3, not negative 3. Please take note. Okay, the negative has been taking care of the movement down. Okay, then you do this. So you are looking at your vector here is vector. What's the name of the vector? PQ. So let me indicate my arrow, then the PQ. Point well made, my professors.
Yes, please.
Okay, so in this case, if I know the angle here, theta, okay, I know my bearing because the bearing will be, so bearing will be equal to 90 degrees plus theta. Is that not it?
Yes, please.
Okay, plus theta. Okay, so at this point, we need to go and find theta, then we are in a comfortable lead. Okay, so quickly, let's see how we can find, okay, theta. We know that if you want to find theta, you use the right angle triangle here. So you go and write, but, okay, tan theta will be equal to, okay, we know tan is opposite. Opposite is 3. Okay, adjacent is 5, so it will be 3 on 5. Okay, so theta will be equal to what? Tan inverse of 3 on 5. My professors, I hope you are following.
Yes, please.
It seems someone has sent me a message. The negative 3 is treated as positive because I said you move down. This is a side of a triangle. None of them should be negative. If it is 3 and it is down, it is still regarded as negative. You don't write negative here. Is that clear, Prof. Blaise? I even said it when we were dealing with the X and Y. Okay, so maybe it's your network or you were not listening attentively. Okay, so your size of the triangle here, the negative will tell you, the positive and negative will tell you the direction of your movement. Okay, so you shouldn't see negative anywhere in your calculation apart from the magnitude. Okay, so but anywhere in your diagram you shouldn't see negative. Okay, so now what do we have? Theta will be equal to, I'm relying on you, tan inverse of 3 on 5. Someone should be done by now. Is it 30 points?
Yes, please.
Okay, so
Point
let me calm
96.
down a little. It seems if I write it to interfere. So let me calm down a little. You will have lines, so you will not encounter this issue. So this is equal to 30
Point
point
9638.
963. It will be 375 something, right? So if
Yes,
if
please.
you take it to be 38, very good. You've done the right approximation. Don't forget your degrees and don't forget your 4 dp. All correct, my professors. Okay, so let me approximate my theta here so that it can equally help me approximate my bearing. So that I'll write less. So this will give me approximately equal to 31 degrees. Do you agree? So I can say that this implies that my bearing will be equal to 90 plus 31 degrees. 90 degrees plus 31 degrees, which will give us what? 101. Is that clear?
Yes, please.
Okay, so 101 degrees. So therefore, your PQ in the magnitude bearing form will be equal to the magnitude was root of 34 units. I'm coming. Those of you with your hands up. Okay, then comma. Your bearing will be 101. Okay, degrees. Okay, so let me see. Couple of hands up. Okay, Prof. The first hand up here is Prof. Stephanie.
Mr. Hackman, please, when I added 90 plus 31, I had 121 degrees.
121, very good.
Yes,
So
please.
those of you who said 101, where did you get your 101? So if 90,
Why you said it?
it didn't what?
You said it yourself.
And you said yes.
No.
Oh, I remember I asked, then you said yes. Okay, anyway, we should waste time. Okay, so obviously it is plus 11, that is give you 101. So this will give you 1, 2, okay, 1. Is it clear now? Issue sorted, right?
Yes, please.
Okay, so 121, okay, degrees. So on that note, okay, you should be able to, okay, do the this one and this one, so which will help you do this. Okay, unfortunately, we don't have time. Okay, please bear with me. I need about 10 minutes of your time, or 5. We need to finish, okay, what we are supposed to finish today. Okay, so quickly, let's look at the next one. Do we have to do the C? Is the explanation okay for you? What is important is you locating your vector, then the angle. You use tan theta to find the angle, and you know the size of the triangle that you are using. Your theta, that contains theta, so opposite adjacent will always be known. Then we will look at that. Okay, so quickly, let's go and look at what the next one. So this should have been a continuation of the C and the D. Then this will be, but you skipped that. So let's look at the last concept that we need to learn today. That one basically will be calculator work. Okay, that will be basically calculator what work. Okay, so expressing magnitude bearing vectors as column vectors. So if a vector AB, which is this, so obviously it's in the magnitude bearing form, where, okay, your vector AB, this is the magnitude of the vector AB, and theta is the bearing. Then if you want to move from the magnitude bearing to the column form, you use this formula. This is just a formula that you need to know, as simple as that. The relative math students, they know this. Okay, now this really core math students, you should know this as well. So this is representing the magnitude of the vector, okay, sine theta, where theta is your bearing. Remember, we said theta is the bearing of what? Because we said, you can see, is the vector AB. So it will be the bearing of what? Of A from B. This is wrong. Do you agree with me that this is wrong? So let me quickly go and change. It's supposed to be the bearing of what? Hello? Who is with me? It's supposed to be the bearing of
B from
B
A.
from
B from A. So let me quickly do that change. Okay, so that's supposed to be A, and this is supposed to be B. So I guess, Prof. Blaze, you are with me now. Okay, you had issues with that. So it was a typo error, which is corrected now. So let's go and continue. So thank you. So then this is what we have. So example, if I have vector AB to B, there's the magnitude and the bearing. So if I want to move from the magnitude bearing to column, it will be, okay, my new vector AB, or my vector AB in the column form will be the magnitude of the vector, which is what? 2 times sine of the bearing, and the bearing is 60. When you are writing it here, don't attach the 0. Don't precede it with 0. Okay, just write the exact angle there. Okay, sine, and don't forget your degrees. Sine 60, then 2 cos 60. The rest will be calculator work, which will give you this. Use your calculator to do this, which I can use my head to do this, because 60 is a special angle. Use my head to do that as well. Okay, so at this point, that will be it for, and then let's go and look at particular examples. Hello?
Ahmad,
Yes, please.
please, just 1 second. Please go to the previous slide. Just a screenshot, please.
Okay, a screenshot. Okay, unfortunately, let's finish. Then you will stay and do your screenshots. All right. Okay. Okay, so quickly take your screenshot and let's go. Okay. Oops. Have I gone back or? Okay. Quickly.
Thank
I
you.
asked of, okay, 10 minutes, maybe 5 minutes will do for now, between 5 and 10. Okay, so I want us to do something. I want to see if we can go back to the magnitude bearing. The first one let's go. I want us to see something. The first one that we did, let me see. What was the bearing? The approximate bearing was 037, right? 037. The magnitude bearing is this, is that not it? Okay, so I want us to pick this particular one, work it out, and see whether we'll get its corresponding column form. Then it means we know how to toggle between the magnitude bearing and the column form. So quickly, let me change this one to, instead of, okay, 40, was it 30 degrees? Yeah, instead of 30, let me quickly do some editing for you to know, then the rest may be I can deal with the status quo. So let me make this one was 037, right? When you approximated. Was it 037 degrees? I think so. All right. So let's see. As for the magnitude, was 5 units. Only that here I have attached the exact unit m there, but it's the same magnitude, 5. The value is 5. Okay, so let's go. Okay, so let's go and see if it will give us the corresponding column form, which was 3, 4 or so. So quickly, this is what we are going to do. A. Okay, we've been given the vector AB, okay, to be equal to its magnitude 5 meters, its bearing 037 degrees. Okay, so now what do we do? In terms of column, we can say that therefore your vector AB will be equal to the magnitude of this vector, which is 5, sine of its bearing. So sine, what's the bearing? 037 degrees. Okay, then 5 cos your bearing angle 037 degrees. Am I right? Hello,
Yes,
am I?
please.
Hey, really? I just advise that
No,
when you are
please.
giving the don't ignore the, what do you call, the 0 before it, and don't forget your degrees. So this is not how you write it. Okay, so you know that it's intentional this time around. Okay, so let's go and do the needful. So listen and listen carefully. I'm drawing your attention to some of the common errors. So the angle there is 37 degrees. This will also be 37, okay, degrees. So I'm relying on you. You should rely on your calculators, and let's see what we are going to get. So you just do 5 sine 37 degrees. Your calculator is in the dead form, degree form. So if you press the equal to, it will give you your answer straight away. So what did you get for the S component? 3
3,
points. So 0, 0,
9,
9,
0,
1.
9.
9, 1. Okay, then what about your Y component? My professors, I hope you are following. So that will also be 5 cos the 37 degrees. So that will give you 3.9932.
9, 2.
Okay, so you approximated, but you approximated to 4 dp. Is that not it?
Yes, please.
But if you look at the one that you want to compare it to, you can see that they were approximated to the nearest whole number. So we are dealing with, so this will be approximately equal to, okay, to the nearest whole number, what do you think your S component will be?
3,
3. To the nearest whole number, your Y component?
4.
4. Okay, so you can see that it's exactly the same thing that we did. It was in this column form which gave us this magnitude bearing. So if you are moving from the magnitude bearing, you have to get the exact column form. Safa.
No.
Okay, so we'll do one more. Always one will not be it's necessary but not sufficient always. Okay, so let's do the B. Then that will be it. Okay, for vector. So you leave a line. B, what are we giving? We've been given the vector PQ. Okay, in the magnitude bearing form. What is the magnitude? 6. Okay, km. What is the bearing? 120 degrees. Okay, so therefore you can get it straight away in the column form because it comes with a formula. So it's not AB, forgive me, it's PQ rather. Okay, so vector PQ. So let me go and do the needful. So the vector PQ, in terms of the column, it will be, okay, don't write the formula. The formula is embedded. So it will be your magnitude, which is 6, sine of your angle here. Here is already 3 digits. So 1 is not preceded by 0. So you write exactly what you have there. 120 degrees. Then 6 cos, okay, 120 degrees. So the rest will just be calculator work. Okay. Let's go. 6 sine 120.
5.19.
5 points.
962.
5.1962.
62.
Okay, then 6 cos 120. I think that will give you
-3.
negative 3. So it will be negative 3. Have you done any approximation here? The first one, the
So
first
it will
component.
Yes,
So you
for the
indicate
yes.
your 4dp. Is that clear?
yes.
Okay. You can end here. Here we don't want to compare it with anything, so you can end here unless you want to take it to the nearest whole numbers. Otherwise, you end here. Is that clear? Here I continued because I wanted you to see the relation. You get it? Moving from that to that basically will be the same. Is my point well made, my professors? Hello, my professors,
Yes,
are you with me?
please.
Okay, so
Yes, please.
thank you very much, okay, for your time and attention, okay, your patience as well. Okay, God bless us all.